everyone to the TARS Community Meetup Canada. And my name is Paige, and I'm the program manager of the TARS Foundation. So today I would like to talk to you about who we are and what is TARS and how you should become part of our exciting community. And so while to start off, the TARS Foundation is a nonprofit open source microservices foundation under the Linux Foundation. And I'm sure most of you here would know about the Linux kernel and the Linux Foundation, which is the world's largest open source software foundation that hosts plenty of projects such as Kubernetes and Jenkins. And the TARS Foundation is one such Linux Foundation project that focuses on building a new generation microservices ecosystem. And now I would talk more about the TARS Foundation. So using the Linux Foundation as an analogy that I use in the start, the Linux Foundation is not just about the Linux operating system, but it also empowers many open source technologies to tackle difficult problems around the world. The TARS Foundation similarly is not only TARS microservices development framework, it is an open microservices ecosystem and that focuses on solving microservices problems. And our mission is to build a neutral home for microservices for open source microservices projects that empower any industry to quickly turn ideas into applications at scale. And we believe that to solve many common microservices problems, we need a robust microservices framework that can support the following characteristic, that is agile development with DevOps best practices, building comprehensive service governance, multiple languages supported, high performance with scalability. So we think these are the priorities that we need to work toward to help many people to transform digitally. And here is some information about the size and the vitality of our TARS community. So the TARS Foundation was launched in March 2020, and currently we have 9 members with ARM and Tencent as our premier members. And for general member, we have AfterShift, Ampere, Calm, API 7, and ZenLayer. And for associate members, we had Nanjing University and Ramanuja College from University of Delhi. So we have so far we have more than 30 projects with 12,000 plus active developers using TARS, and more than 100 companies in different industries are using TARS, and that includes like in edge, eSport, fintech, and streaming, and many more. Right now we have more than 300 contributors from different companies who are actively contributing code to the TARS GitHub repository. So returning to our discussion about the TARS Foundation's mission. So this is the microservices ecosystem that we are building and upgrading to build for our microservices community. As you can see, our ecosystem supports different underlying infrastructure in the bottom here. And development framework, service governance, and we also support for different multiple programming languages. And we also have integrated DevOps tools. And on top of everything, we have great potential to host different applications on the top. And to like quickly sum up, so TARS is a mature high-performance microservices framework that supports many functions and is already being used by many companies for years. So this is a timeline of the achievements and milestones made by the TARS Foundation in 2020. And here we want to show that the TARS Foundation is constantly making progress and to grow our ecosystem. For instance, last April, we have open source TARS Gateway, which is here, and TARS Benchmark, TARS JMeter, and Kubernetes TARS, which is a Kubernetes native solution for TARS framework. And we are constantly growing our ecosystem by including more projects. And we are also taking advantage of and creating opportunities to engage with our communities. For example, this meetup is a way for us to engage with developers to have conversations about microservices and other trends, technology trends. And we also have a lot of events and conferences where we have speaker, we bring our ambassador, maintainers, or even our members to share their story and their technologies. Okay, previously I presented you the microservices ecosystem, and now this is a complete landscape in which we envision to incorporate our microservices ecosystem with other open source projects in the near future. We divided our landscape into 4 layers. The bottom is the infrastructure that includes different chips, clouds, and containers. We also will support additional programming languages in order to fulfill more different needs of developers working in different teams. We will moving up, we have the storage and protocol layers. And the middle is the platform layers that enforces business logic. And for that, we are aiming to build a framework, service discovery, service mesh, logging, monitoring, configuration, and many more. And in the upper layer, we have the application layer that includes API gateway, deep learning, edge computing, and the TARS lab. And so basically the TARS landscape is update. So if you are interested in learning more about it, you can check out the URL here. And just to add on, so the TARS landscape is actually modeled after the CNCF landscape. So this tool can really help us to navigate our community. So, and then we have the TARS Foundation Greenhouse. So it is actually it contains what we currently supporting. And for the TARS lab, we have the TARS benchmark, TARS JMeter, TARS tools, TARS Java Star, TARS open testing lab. And for platform, we support TARS framework, TARS TCR, TARS log monitor, and TARS gateway. And for storage and protocol, we support TUP and protocol and Dcache. In terms of infrastructure, we have the Kubernetes TARS, which is a Kubernetes native solution for TARS. And then we also can deploy TARS via Docker. And for multiple languages, programming languages, we support like C, TARS, C++, and Go, Java, and Node.js, and PHP. Okay. So the TARS Foundation's community is actually quite active, and we typically do a lot of events or activities to promote communication among our contributors and members throughout the years. And we have different mailing lists dedicated to our community so that we can have more discussion to exchange ideas about microservices and other technologies. And for Meetup like this one, we typically host once every 2 months to meet developers in the TARS community. So and it is our way to encourage discussions about microservices strengths. And conferences will be bigger events that we and other sponsor host to share technologies and achievements. And we are actually planning to host a larger scale conference uh, this later this year's, I think. And so please stay tuned for more exciting news from us. And so here are some photographs and poster of the past events we have participated or hosted. And the one on the upper right is the Cloud Native Plus Open Source Virtual Summit China 2020. It was a pretty large scale. It was a large scale online events, and the number of people who attended was more than 60,000 people, and we estimate that our PR coverage had went beyond 120,000 people. And during this event, we have representatives from our member companies, which include ARM, Ampere, and API 7 to talk about their use cases. And we also have our maintainers to share about their projects at the event. And on the left side, we have the Linux Foundation Day in Tencent. So Tencent is a premier member of the TARS Foundation. So we were able to host this in-person events to along with the governing board of the Linux Foundation within at Tencent. So this was a company-wide event to evangelize TARS and open source values to more than 200 developers at the conference, and the press release reached more than like 40,000 people. And TARS Microservices Day was also was part of a series hosted by the Linux Foundation training that was dedicated to discussions about Kubernetes, Hyperledger, and TARS. And through this online event, we were able to share about the TARS Foundation and TARS use cases to more than 100 people who attended this online event. And it was a pretty and it was and TARS Microservices Day is gonna be a more regular event that we host every year. So, and we are also hoping to plan more meetups in the future, like this one. And I know due to the pandemics, we were unable to host a lot of in-person events, but as we move forward with the pandemic, I believe we can see more TARS community people in person. So I hope by now you have a better idea about the TARS Foundation, and you will be interested in participating in the TARS community further. And next, I will explain the different ways for people to get involved with our community and join the join the foundation. So at the individual level, we had different roles for people to showcase their talents and abilities in our community. So we have maintainer, committer, contributor, and ambassador. So, and these are the major forms of contribution to the TARS community. So to become a contributor, you basically just need to submit a pull request to our GitHub repository and have it merged to the branch. And then if you want to upgrade from contributor to a committer, you will need to present more significant contribution, such as like submitting 5 pull requests or fixing major bugs. And by becoming a committer, you have the right to oversee the code quality of the projects, respond to pull requests submitted by the community, and have the chance to join our project management committee, which is a technical governing body for our technical projects. Next level is maintainer. So for maintainers, they usually have deeper knowledge about TARS technology, and they can actively put forward projects and ensure code quality. And they have the chance to become a PMC chair and even join the TOC, which is the Technical Oversight Committee, and that is a foundation level governing body. And so, and then we also have the ambassadors. So our ambassadors are TARS enthusiasts, and they participate by giving speeches at community events, writing technical articles or blog posts for us, and then also like helping us to organize community events can also qualifies you to become an ambassador for TARS. Next, let's talk about some resources from the TARS Foundation to the community. So if you are completely new to TARS, you should take advantage of this free training course, Building Microservices Platforms with TARS. So this is a collaboration between the TARS Foundation and the Linux Foundation training. So this course is actually pretty hands-on to teach students to develop a microservices program, and it can quickly help you get a sense of the TARS platform and utilize it. And for our next session, Isabella will also give you a snapshot of the course, basically. And additionally, we run internationally recognized certification program along as a partnership with the Linux Foundation. So at the moment, we have the certified partner program that is a enterprise level certification that is for our member companies. And right now we are working to release certified TARS service provider program that is for individual developer to demonstrate the skills, knowledge, and competency to perform the project's operational responsibility. Basically, it's a TARS certificate for individual developers to acquire in order to show their ability of using TARS to develop microservices programs. And we also welcome outside open source projects to join the TARS Foundation. So the TARS Foundation is actually establishing a series of mechanisms for different open source projects to join us. And then we have an incubation process. So basically, after a project has agreed to join the TARS Foundation, we will work with the project's a committer to help them tailor a appropriate incubation and maturation route according to project's circumstances in order to grow the projects further. And right now we have a project governance model that provides a general set of requirements in the area of code licenses and copyright, releases, quality, community consensus building and independence. And we have 2 project stages, and projects actually join the TARS Foundation as an incubation projects. And after meeting all the incubation requirements as defined by the 7 criteria in the project's governance model, the projects will wish is graduation. And during the whole maturation process, our governing board will actually help the projects form its project management committee and a user community. And the TOC, our technical governance body, will also look after these projects by reviewing each project's unique situation, providing strategic decisions, and assisting with their overall development. And if you, so I would like to just encourage people who to donate your projects to the TARS Foundation. And there are many benefits associated with that, but because we have limited time today, you can definitely reach out to me if you're interested after the event. Okay, so throughout my presentation, I'll be mentioning our membership, and now I will explain how the TARS Foundation membership works. So at the TARS Foundation, we have the associate member, the general member, and the premier members. So members of different level all enjoy their respective benefits in different areas. And so, and here's some quick run through of the membership benefits. So we have community engagement, and that includes speaking opportunities and an ambassador program and many more. And you'll be empowered as a member, you'll be empowered to educate communities around the world to learn about your technologies and your use of microservices. And when you join the TARS Foundation, you also join the Linux Foundation, and this allows your organizations to engage with the larger open source community, including representative for more than more than 1,000 of the top technology company around the world. And members of the TARS Foundation, we're also able to network and help shape the evolving microservices ecosystem. And they can help shape the training course and certification programs and ensure that your version of projects supports the required APIs, for example, and provide technical guidelines to our technical governance bodies, such as and also PMC, etc. And you can also showcase your thought leadership and industry commentary, as well as share technical walkthroughs for microservices projects here. And you are also welcome to participate in the planning and organizing TARS Foundation's events and conferences in order to reach a wider audience. Company also joined the TARS Foundation as end user. So end user are not only able to gain greater brand exposure via TARS channels, but they also have the opportunity to engage conversation with other end user and our members to form potential collaboration opportunities. And we also welcome our end user companies to contribute case studies of using their technologies to solve challenges they face, and when developing microservices solution, for example. And this is an excellent way to showcase your company's innovation and your technologies. And you can actually find different case study displays on our website. And this is a great opportunity for our end user to exchange their technical expertise with the broader community and inspire more conversation to innovate. Okay, so that a buzz was pretty much what I'm sharing for today. And if you have any questions about TARS Foundation or how to join the community, you can ask now. Oh, okay, I'll need to go back to the end.
Does anyone have any question?
Yeah, here's are some of the channels you can find us.
Yes, so as Paige mentioned, I don't know if you remember the greenhouse image. So TARS is composed of many projects. So we have the framework, we have the one specific project for each language. So if you're interested to contribute, you can check out the GitHub and contribute to the one you feel more familiar with. And that's very cool. Yeah, and also as a
Yeah.
mentioned, you can contribute in many different ways. So for example, now I'm an ambassador, so I create blog posts or participate in conferences for the TARS Foundation, but you can also be a member or a contributor in the source code.
Yeah, we welcome any form of contribution, and it doesn't have to be a strong commitment, and we just welcoming it and inviting everyone to join us to have the conversations about microservices.
Okay, so
Okay.
if no one has any questions, maybe I can present about the project itself.
Yeah, so yeah, let's Isabella to share about the TARS framework. If
Can you see my screen?
Yes, I can.
Okay. So Paige was talking about the TARS Foundation. So the foundation is pretty new, but the TARS project, it's a very mature project that exists over a decade. So I'm gonna talk about the challenge that TARS helps to solve in the microservice technology. I'm gonna show a little bit of how is the TARS dashboard. And in the beginning, I'm gonna talk about microservices for those who are not familiar with the term. So microservice is like a trend now. So experts predict that by 2022, 90% of all applications will be developed using the microservices architecture. And the trend in this year is that most developers will move away from locally hosted applications to the cloud. And this is because the applications are growing a lot and they need scalability. So by moving the applications to the cloud, that will help businesses to minimize downtime, optimize resources, and also reduce infrastructure and maintenance costs. So what are microservices? So microservice is actually an architectural pattern in which the application is decomposed into many small interconnected services. And those services, they are like loosely coupled and they can be developed, deployed, and maintained independently. So each part of each microservice is responsible for doing one small task that can easily be tested and deployed and developed. So as I mentioned, so it's a single application, it's a suite of small services. So each service runs its own process and communicate with lightweight mechanisms such as the HTTP resource API. There is a very, very bare minimum of centralized management. And because each small application, each small service is developed independently. So that means that they can also be developed in different programming languages and they can use different data storage technologies. And that gives more flexibility for development teams. So everything started with a monolithic application and now things are moving to microservices. So in a monolithic architecture, the software is self-contained. So the components of the program, they are actually very interconnected and interdependent of each other, and they are not loosely coupled. So each component is actually associated with other components, and they kind of need to be represented in order to be executed or compiled. And in case we need to update one of those components, then we need to redeploy and update the whole application. And this is a problem when you have a large scale application. However, in microservices, each module is independent. They can be changed without affecting other parts of the program. And with that, we reduce the risk of making other components more prone to have bugs. And we can also create unanticipated changes in other components. And when we break down a complex problem, a complex program into many smaller ones, then that means that the architecture will be scaled and will be easy to perform maintenance tasks. So there are a lot of good things about microservices. Here's an example. So in the left hand side, we have how a monolithic architecture works. So we basically have different layers of applications. So we have the user interface, the business logic, and the data access layer, and only the one specific layer access the database. So if we have a point of failure in that specific layer, the whole application will crash. However, in microservices, we're gonna decompose those layers, let's say, in many different microservices, and each of those microservices will have access to the database. So if something fails, will only be that very specific part of the program or the application that will fail. And many industries, they changed to microservices, and they have very interesting use case. For example, Netflix, they had a huge problem in 2007. They were still working with DVDs, and they had a major database corruption that they were not able to ship the DVDs to their members for over 3 days. So this is because they were using a single point of failure, a monolithic architecture, and that architecture could not be scaled and could not be reliably distributed, for example, to the cloud. So they changed it to microservices in 2009, and that allowed them to solve the scalability issues, also service outage and reduce costs by having cloud costs per streaming instead of data centers. And now Netflix streams over 250 million hours of content every day for more than 140 million subscribers. Another example is Uber. So in the beginning of its creation, Uber was struggling to develop and launch new features and fix bugs, and also integrate new chains to the source code. And then they decided to move to microservices. So now each function in the app is a different microservice. So we have, for example, the passenger management, the trip management, and each of these small parts is actually a microservice. And that allows them to grow the application and also have more reliable fault tolerance. And another example is the Amazon. So Amazon, in the beginning, also they had to refactor the whole monolithic architecture, and they changed everything to microservices. And that allows them to grow their user base, also to scale their requirements, and to incorporate new features easily. So this change led Amazon to have a lot of different solutions, and now they even have the Amazon AWS, which is a microservice architecture. But so I hope that so far I convinced you that microservice has many advantages. However, there are also many challenges. So usually there are difficulties of development, of service governance, of having multiple programming languages, and also having high performance and high concurrency. And I'm going to show you how TARS try to address those problems. So nowadays we have basically 4 categories of microservices. So the first one is the one that doesn't provide service governance. So you cannot have access to the metrics and the statistics of the service. And in that category, we have gRPC. We also have service mesh, which is a way to communicate, a light way to manage the communication between services. So we have Envoy and Istio. We have a single language microservices such as Spring Cloud, which is developed in Java. And we have microservices that support multi-language and governance, which is TARS. And now TARS is working to incorporate the service mesh also into the framework. So how do we address to solve the business, to address the development problems, is that the developer has to focus only on the business logic, and we do that through encapsulation. So developers can create their own protocols, their own transmission, and they can use their program language of preference. So TARS supports many protocols. So we have IDL, serialization, protocol codec, and also interface-oriented programming. For transmission, TARS supports TCP, UDP, and you can configure that. Also, TARS supports RDMA and other plugins, and you can also build your own plugin and incorporate it into TARS. And TARS supports programming features such as future promise and coroutine. Concerning the service governance, so TARS has support to service register and discover, load balance, overload protection, and distributed tracing. So here in this image, for example, we can see that the client requests the address to the two nodes SVRA from the register node, and then access the service by load balance strategy. And then the service will report the keep alive message to the node, and the node will report to the register to know which services are actually alive. And then the service will be able to monitor the other nodes of the service by doing a remote log, remote configuration, distributed tracing, authentication, and things like that. And also, TARS supports multiple programming languages. So as Paige mentioned before, we have Go, Java, PHP, Node, and C++. And we are working to incorporate other languages such as Python. So that allows development teams to develop the application in different languages, and then they can be easily integrated into TARS. And also concerning the performance and high concurrency. So we have compared TARS to other microservices framework, and we can see an increase in performance. So here in this plot, we have compared TARS in multiple programming languages with Spring Cloud and gRPC. And TARS C++ seems to have the better performance when we compare the number of transactions per second. So that will help companies and projects to reduce costs and provide high performance and high concurrency architecture. So here is we have some examples of the industries that TARS is helping today. So we are working on the gaming industry, fintech, social network, e-commerce, telecommunication, education, video streaming, edge computing, AI, and yeah, so there are a lot of projects in China, such as QQ, WeChat, WeChat Pay, and they TAR support millions and millions of users every day, and it's very scalable. So concerning the deployment, we have a series of videos on YouTube. It's called TARS for Beginners. So we teach you how to deploy TARS. You can do that via Docker and manually by deploying all the dependencies manually. So it's not very complicated. And I hope if you're interested in TARS, you can check the videos out. And there is also the course that Paige mentioned on the Linux training that you can follow the course, know more about TARS, and then follow our videos to see how to deploy TARS. And we also have the TARS dashboard that I'm going to show you now. So after deploying TARS, for example, via Docker, which is the easiest way, you take you 5 minutes to deploy it. You can develop your own applications. So here I've created an application, simple application, Hello World, just to show you. And so when you go to operation, you can deploy your own services. So you can set up everything here, and then you can choose to expand the service, manage the application, see which ones are alive, who created when, and things like that. Once your application is deployed, you have a real-time service status here, and you can also monitor different things. You can also debug your application directly here in the interface. So for example, here, I have a function that returns me hello world, so I kind of know it's working. And yeah, so you can do different types of monitoring. And this is, so first step was my first application. And then we also have the TARS framework, where you can do all activities of service governance and check out the status of your services. Yeah, so that was basically it from my side. I encourage you guys to check out our GitHub and see how you can contribute to TARS. So you can start with documentation, you can start by improving the source code, you can develop new features, you can contribute to the TARS framework, to the TARS C++, Go, the one of your preference. And yeah, let me know if you have any questions, and if you're more interested to know about how to deploy TARS and how to use it, we can definitely talk about it. Thank you so much for your attention. Does anyone have any question? Okay. So yeah, Paige just sent in the chat the TARS training course. So yeah, you can take the course for a more information about TARS, and you can also check out our videos on YouTube to know how to install and how to deploy it. And then you can apply it to your own projects and see how it scales. Okay. So since no one has any question, I guess we can move to the next presentation. Jinyuan?
Hi.
I'm sorry
Hello,
for saying
hello,
your
hello.
name wrong.
Yeah, I'm here.
So if you're ready, you can share your screen.
Okay. Hello.
Hello.
Yeah, okay. Okay. Because my hotel's network is not good, so I have to close my camera. Okay.
No problem.
Okay. Okay, let me share my screen. Wait for a moment. Okay. Okay, can you see this title?
Yeah, now yes.
Okay. Hi everyone. I'm here in Beijing, China, to share with you the evaluation of API gateways with mirror services and how Apache API 6 is doing it. Before I start, I'd like to thank Wang Zhen for encouraging me to experiment and get involved. And I would also like to thank you, Apache Software Foundation and community of Apache API 6 for making our internet thrive. And finally, I'd like to thank the TARS Foundation, a nonprofit open source. Yeah. Okay. First, let me introduce myself. Okay, I'm Zhu Zhiyuan from Zhiliu Technology. Yeah, API 7.ai, the original manufacturer of the cloud-native high-performance open-source gateway Apache API 6. Currently working on the traffic portal, the API gateway. In addition, here's my here's my GitHub profile, and let's get down to business first. Let's talk about mirror services. Okay, the first question is, what are mirror services? Mirror services are a service-oriented architecture in which an application is developed as a collection of small autonomous services modeled around a business domain. Each service in a mirror services architecture is self-contained and it implements a unique business function. Each mirror service is responsible for its own data model, and it can communicate effortlessly through multiple instances. Therefore, the failure of one service doesn't affect the entire application. Okay, so we want to know, how does it work? Depending on the size of the application and business requirements, a mirror services architecture can contain the following concepts. Look at the right picture. Okay, it contains API gateway. The API gateway is an entry point for the client. The client needs to call the API gateway, which forwards the call to a specific service at the backend. The API gateway can aggregate the responses from different services and return them to the client. The next one is mirror services. They are small services that are used to perform certain business capabilities, such as user registering, getting lists of current orders, etc. And third one is database URL. Mirror services can either share the same database or have independent and isolated databases. And finally, the communication between mirror services. They can interact with each other using various protocols, such as RESTful APIs or messages. Okay, the second question is, what are the benefits of mirror services architecture? Here are some benefits. The first one is component isolation. Mirror services architecture allows developers to build loosely coupled services that can be developed, modified, and extended individually. The second one is simple technology stack upgrade and maintenance. Each mirror service technology stack can be different and replaced without affecting other services. And next one is mirror services architecture overcomes speed and productivity issues by breaking applications into smaller services that can be developed quickly. They are good for developers. Different teams can continue to develop on different components without having to wait for another team to complete a large chunk of functionality. And it's easy to understand. Each mirror service has a smaller code base that's easier to understand. And the last one is it has good scalability. By using mirror services, the effort required to discover slow bottlenecks in application is reduced. It allows each mirror service to be scaled to address identified bottlenecks and provide a better overall user experience. Apart from the considerable advantages of mirror services architecture, development teams may encounter certain drawbacks while building applications using mirror services. Let's take a look at existing challenges and how to solve it. Okay, we have tracing, logging, security, and other issues. The first one, tracing. When moving from a monolithic architecture to mirror services, tracing can become very difficult. If an update made in one service affects other services in the application, it can take a lot of time to track the impact of a request on other services. And it's better to keep timestamp log records to overcome the problem of tracing. Keeping logs will help developers to find problems quickly. If developers also use different programming languages to build different services, then there may be some tracing the services to fix the problem. Another way to overcome the problem is to stick to one programming language when building applications with mirror services. And mirror services are executed on multiple hosts. As a result, developers may need to deal with various services running on different machines to run a business requirement. This results in mirror services generating log messages that are distributed across multiple hosts. To troubleshoot any issues, developers need to go to different hosts and search for all logs, which is a time-consuming process. It's recommended not to distribute the generated logs across multiple hosts. Instead, it's better to send the logs to an external centralized location. Developers can easily access log information from one location. If we use an AWS environment to host their applications, cloud providers such as CloudWatch offer services to store and monitor logs. Okay, in monolithic applications, processes communicate with each other locally. However, applications built using a mirror services architecture have multiple services scattered across a multiple cloud environment. Each specific function, which has to communicate externally through APIs, increases the attack surface if proper security mechanisms are not implemented when building the application. Okay, as for the API version, whenever a change is made to any service, the developer must deploy a new version. Each feature in the application may require maintenance versions in order to interact with each other seamlessly. To get rid of multiple versions, it's recommended to use an API gateway to create an alternate domain name that redirects all requests to a new instance, thus saving the developer the time of updating the instance each time the version is updated. If the version is maintained, developers can move back to the old version whenever needed. They could try Apache API 6, yeah. And as for the communication between mirror services, when a client sends a request via the HTTP protocol, it receives a response back. If this response is dependent on the interaction between mirror services over HTTP, then it may result in higher response times. Using network calls such as AMQP instead of REST APIs for internal communication between mirror services can minimize response times. Okay, we are facing so many possible challenges to be faced. Since there are so many problems with microservices architecture, let's see what Apache API 6 has to offer. Okay, Apache API 6 is top project level in the Apache Software Foundation, donated by our team into 2019 and graduating in 2020. It's a cloud-native, high-performance, scalable, low-latency API gateway that's an essential component under the cloud-native architecture. It provides rich traffic management features based on etcd and Nginx. Let's see what features it provides. It supports for multiple protocol conversions, such as TCP or UDP, and also supports double MQTT and gRPC. Second, it supports for complete dynamic capabilities, such as plugin hot loading, proxy writing, serverless health tracking, and traffic splitting. They are very useful for many companies. Third, it supports for powerful route matching capabilities, such as full path matching, use of Nginx built-in variables, etc. Fourth, it supports for a variety of security authentication plugins, such as GWT, symbol authentication, IP black and white lists. Fifth, support for operations and maintenance friendly, such as built-in dashboard, global rules, etc. We have other advanced features, of course, that are not listed here. Since it contains so many features, how it is completely implemented. First, look at the architecture of Apache API 6, with the data plane on the left and the control plane on the right. The right control plane writes routing rules to etcd by calling interface, while the left data plane will automatically get configuration data from etcd and take effect in real time. When traffic passes through Apache API 6 from top to bottom, dozens of built-in plugins will complete the function of traffic operation in turn. The various functions mentioned above are realized by these plugins. They are here. It includes rate limit, auth security, logging, custom plugin, and so on. As an open source project, in addition to being stable and feature rich, a healthy community can make it run longer and faster. In the past months, Apache API 6 and its sub-projects have merged 2,050 plus PRs with over 20 talented contributors. On the right is contributor growth curve for Apache API 6 since its inception until now. How has it managed to be so active? It has reached 150 in one project. First is adherence to Apache community culture. All discussions must be public. We send to a mailing list for communication, and any subscriber has a right to read and give feedback. The second is that the contributors are very good, and they are attracted by the activities of the Apache API 6 community and takes the initiative to find problems and solve them. The next one is developer relations. We hold regular online and or offline developer conferences to provide direct feedback channels for developers in each city. in China, of course, in China for now. Secondly, we also respond quickly to developer issues to assist developers as soon as possible. And third, we try to encourage contributors to mentor each other and encourage them to meet each other and make friends. Lastly, we observe active contributors and at the right time, lastly, we will observe, we will observe active contributors and vote on them at the right time, to select them as our members, which is also an honor for them. By the way, we have some partners like Apache Skywalking. We have encountered some problems in working with a community, but that doesn't stop the community from growing. To see what the problems were and how we solved them. When there are multiple contributors agreeing on the same issue, we choose to vote to be able to resolve it. And we have found that it's not that hard to communicate in English. So we are encouraging more developers to use English when communicating on mailing lists or GitHub, mainly for Chinese. And I'm so impressed that community contributors helped design the Apache API 6 website and build the documentation set, just like this picture. This is the homepage screenshot of our website. And there has a lot more to share, and thanks to them. By the way, what we get in the last 2 years, I think an active community, which we hope will continue more consistently. And some enterprise users who are users of our open source products, they are active in bringing in internal features, fixing bugs they found, and introducing them to Apache API 6. By the way, we have more great contributors. Thank you very much. And finally, here is a screenshot of our team page. We have 23 PMCs and 11 committees, all of whom are very good at helping the community grow. Thank you all. Okay, here's my talk. Thanks very much. Yeah. Hello.
Sorry, I was on mute. Thank you for your presentation. Does anyone have any question?
Okay, this is my first time to share with. Yeah.
Yeah, so may I have a question? So you talked about API 6, but in your description, you are from API 7. Is it the same project?
No. No. API 7 is our team's product, and Apache API 6 is belong to Apache Software Foundation.
Okay.
Yeah. Yeah.
And I was wondering if it's possible to integrate or to replace like service mesh, like from Istio or Envoy by using this Apache project.
Yeah. Okay. I'm a web developer, not backend. Yeah.
Okay.
Yeah. Yes.
Okay. So does anyone have any other question? So we are supposed to have a break now to stretch our legs, grab a cup of coffee. Do you guys want to have the break, 15 minutes, or you'd like to continue? What do you prefer?
Continue.
Yeah, break. Maybe.
Yeah.
Okay.
How is everyone doing?
Sorry, Paige?
How is everyone doing? You can unmute yourself.
Like, if everyone wants to take a break, it's good, but I'm also ready to present if everybody agrees.
Okay, so maybe we can continue. So before Javier's speech, I'd like to invite you guys to answer a survey about like just giving us some feedback about this meetup so we can improve for the next time. So I'm gonna send the link here in the chat and it should take you like 2 minutes, less than 2 minutes to answer, very fast. So Javier, if you're ready, you can share your screen.
Can everybody see my screen now?
Yes.
Excellent. Well, the title of my presentation is Microservices, Divide, Decentralize, and Rule. I would like to share with you our experience working as a startup. Like we see that many big companies are using microservices, but us as a startup, how we use microservices, what we have learned about microservices, and how they have helped us to develop as a startup and succeed. And also what challenges we had encountered on our way. So I would like to start my presentation with a quote. This quote was made by ex-Mexican president. It says, "Today we know that centralization and big bureaucracies have not, as promised, been the answer for promoting better opportunities for society." I like this quote that is related to centralization because we always that we find a problem on our society, we find a problem can be on IT or any other field. We always go back to nature, we look how the nature is solving these problems and we try to replicate it. And sometimes we come back with solutions and then these solutions bring new problems. Then we go back to nature, see how they are solving this and we try to replicate how they solve this and we try to implement it. So I would like to also start by doing some analogy. I would like to talk a bit about jellyfishes. I know it doesn't sound that relatable, but jellyfishes are an incredible animal. They don't have a brain, they don't have a skeleton, they don't have blood, and they are able to retain its shape. They are able to form structures and so on. And how do they do that? Like if you take a jellyfish and divide it by half, it will replicate in other jellyfish. So how do a jellyfish get enough structure without an skeleton or organizational chart? So it's able to retain its shape? Well, they create a living manifesto of values by allowing other organisms to be part if they share the same values. These values are fed into aims, ways of working, governance, stewardship. That is how we look collectively to this particular thing that will be the whole swarm. And before continue talking more about jellyfishes, I'll go back to IT to what is a monolithic architecture. We also have the eighth theory, that is the theory of everything. That is how everything is supposed to be connected. And we ourselves are composed by many services that we can call the cells, and we form our groups, and that groups become later other groups. And like we also on the TARS Foundation, thanks to the invitations, now we're making community and improving things. So going back to the monolithic architecture, a monolithic architecture normally is always running on a single server. We have the UI, the business logic, and the data access on a single server. We normally share the same operating system, the same libraries, and because of that, we are limited also on the version of the libraries and many other things. This is an example of a simple CRUD application, monolithic, where we have the client, an API, we have a database, all running on the same operating system, sharing all. But monolithic architectures are here to stay. They are not in the past. Sometimes they are the most efficient, and we also have to evaluate our applications to see if it's the best or not to be monolithic or maybe distributed. One of the advantages of a monolithic architecture is that they have a simpler design. It can be cheaper for simpler applications. We have all the logging, configuration, performance metric on the same environment, and we have only a single attack surface. But they have many disadvantages. One is that we have a central server, a single main operating system. They can be difficult to manage, difficult to scale a single component of it. It's difficult sometimes to manage different versions of different programming languages, dependencies, libraries. They are prone to request saturation. And if one part is saturated, the whole thing will get saturated. And if one thing changes, the other can start to fail on chain. And then we have the microservices architecture that we divide our main architecture on components that can be running on different servers, machine containers, jails, whatever. And now I would like to see, do they look familiar? The jellyfish and the microservices architecture? I make the analogy because every group or organizing unit is another jellyfish. Then the basic shape can be populated with whatever else needed, or if we don't like a piece is not working anymore, we can just disconnect it. We can do a new piece, connect it to the whole thing, and get our application working. Microservices have a lot of advantages. One is that each component, we can make it scalable dependent on our objectives and business objectives. We can have multiple architectures on the same total component. We have modularity. If one component fails, it's easier to isolate it and see what's going out there and why is it failing. But they also have disadvantages. Sometimes the architecture can get really complex. We have cross-cutting concerns that we may have multiple logins on different places, multiple performance metrics. And also that every component we have, it has to be tested individually. And it can be also sometimes more unsafe if we don't secure all our access to our microservices. So I would like to talk about the company I work. I am an artificial intelligence developer on IoT. We are artificial intelligence driven startup that we try to do human resources using artificial intelligence. At IoT, we combine artificial intelligence with human intelligence. We develop state-of-the-art artificial intelligence software solutions to both for the business and people-centric. It was born from a single idea: make the people of the heart of the organization again. Even we are automatizing human resources, we want to take back the human factor to the human resources. So in a startup environment, we work with many people that has many different talents. We work with researchers of different universities. We work on the state of the art, and all these people work on different programming languages. They have different operating systems and different talent. So microservices have really allowed us to work all together on single different components without saturating. I would like to share a little piece of an architecture we have on the recruitment platform. Every piece we see here, like we have an AI model that will be run. It's a different container or machine. So we have our front end and some of the recurrent architectures that we have for each client, like the database and search engine, are divided on microservices, and in other paradigm will be all in the same. So in this way, we're able to isolate the failure. If we have a failure on one client, it won't affect our other clients. This is a little bit of the technologies we use. We use SQL Server because business reasons. We use Python for our artificial intelligence models and some of the APIs, JavaScript for our front end, Elasticsearch for our search engine, Git for our code and continuous deployment. Windows for storing our SQL Server, Docker. Everything is running on Kubernetes, and we reprogram recurrent architectures using Terraform. On Ariodis, so we have this, that many Python components have library conflicts between each other. We have, as I said previously, different talent working on different platforms. What works in one computer may not work in other. And each component has a different resource load and a different number of requests. So in these ways, we can isolate failure in case it happens. This is a more detailed view with the technologies we use of a part of the architecture. I will go a bit more technical on how we do a bit of the thing, just to share how we use microservices. For example, after we've done some research and built a data set, we'll do a CI pipeline to test the application, see that everything is running well. And after that, we have other that will process our data. We'll upload it to an blob storage. And we will have next other pipeline that will take the clean data. It will train the model and upload it to the blob storage, where each model will be a different version. And then we will have other pipeline that will take that model and deploy it as an API. Then from the front end, the user will upload some documents. Our AI model will take some enrichment of that documents and take it back to our database. And on our database, we have different versions of SQL Server running. And we have an indexer for each client that will take this information from the database and feed it to our Elasticsearch engine. All this recurrent structure of each client, we program it using Terraform. And all is presented on also, all the front end is running on a single container, so the user can see it. So I would like to share some of the tips I have learned and we have learned by working with microservices. One is to codify the infrastructure of recurring structures. If we are going to have multiple times the same structure, like in our case, like we need maybe like a model, database, an indexer, all these parts we can codify it and plan it well, scale it if it's necessary, and deploy it using Terraform. Other really important thing is reduce our attack surfaces. On a single application, as I told previously, we have a single access layer, but on a microservice application, we may have multiple access layers, not only from the front. If we don't do it correctly, we may expose different parts of the application. So an attacker, maybe this part is not vulnerable, this part may not be vulnerable, but if we expose one part, an attacker can gain access here, and there are techniques like pivoting where an attacker can expand to the other machines, even if it doesn't have direct access to it. So it's really important to just expose the part that needs to be exposed to the public. And now this is a bit contradictory, but it's important to centralize the access logs and the system manage and our performance metrics, because if we have all in different places, it's different to have the whole picture easily, and we can lose many things or maybe spend more resources than we need. And the next tip, I would like you to give it with this piece of comic. It says, Carl quit. He was the only one who knew how to program the legacy system. It can be that hard. Go and figure it out. Then he sees and he says, well, what is this? So microservices give us a really big advantage. That is keys. Keep it simple, stupid. And I would like to emphasize it with this quote. The straightforward code is always easier to read than layers and layers of abstraction. Many effort has been put into some programming language to try to have a bit of modularity. So built into that, we can have many layers of abstraction that can make it sometimes more difficult to refactor or adapt the code. So microservices really allow us to write simple code, and it's really recommendable to take advantage of it instead of having a lot of layers of abstraction. And now I will like to share how we can overcome some cross-cutting concerns of Kubernetes, mainly related to networking and security. One thing is we should communicate the containers on a pod using loopback, so they can only communicate between themselves. Then the pods itself will be communicating themselves using cluster networking. And we are only going to expose an application on a pod that we're only going to expose the app running. So we don't expose nothing else. And also use services to publish services only for consumption in our cluster. What I mean with this, for example, make a pipeline that will create a service and then other pipeline. That pipeline will be the only one who will have access to that pod, but there is no other way to access in that pod. So I'll share with you like what is a monolithic architecture, a microservice architecture, its advantages, disadvantages. I compare it a bit with jellyfishes. I share a bit with you the general part of our architecture and some tips. And I really we're learning every day about microservices and how to improve our practices. So any advice or question, I will be more than happy to answer to you. Thank you, and thank you to Isabella and the TARS Foundation for the invitation.
Thank you, Javier, for your presentation. It was a very interesting presentation. I like the analogy with the jellyfish, and that you brought your experience and sharing how we can integrate cloud, microservices, AI, and different kinds of technologies. I'd like to ask you if you, so this is a new project. Did it start in a monolithic application and then you guys had to migrate to microservices?
No, fortunately, since the beginning, like we have the advantage to work with many researchers, so it was a must to start with microservices. But it really, I think, for startups, is really the way to go, because as a startup, you are always trying, failing, and sometimes changing really fast. So microservices really allow us to do that and really like focus on different parts, every person, and then just connect them together.
Cool, cool. Yeah, so thank you for accepting the invitation for your presentation. Does anyone have any other question to Javier? Comments? So no. So now we should have our open discussion. So I'd like to know if anyone has any question or any topic that you'd like to discuss with our speakers, or if you want to know more about the TARS Foundation or anything specific about the presentations from today. No. So maybe, Paige, maybe you can show a little bit about the blog posts that we've been writing, the videos on YouTube and the GitHub, so they can get familiar with it.
Yes, absolutely. Yeah, so yeah, I also want to just thank you all for sitting through this presentation event. And thank you all for attending, and thanks to all the speakers who are so wonderful to attend this event and share all the interesting contents with us. And I would like to point out some TARS Foundation channels here so that we can better stay connected. And I want to show you guys the TARS Foundation website first. Okay. So actually the TARS Foundation is releasing like free ebooks every other month and through our mailing list. So we encourage you to subscribe to our mailing list so that you can get all the informations and updates from us. And after you subscribe to our mailing list, we will be sending you all the 4 ebooks that are about microservices and open source community, and they are quite informative and educational. So it's definitely worth a read if you have some spare time. And will also give you we also send out monthly newsletter about the TARS community, and then we will highlight some of the article from our TARS Foundation and our ambassador. And if you go on our website and go to newsroom, you can see all the articles that we have published, and they are pretty interesting, and it's definitely worth a read. And we also have like Chinese and English channels, and if you know Chinese, you can check out the Chinese version of our website. And then, so we were talking about the training course, and you can actually, if you're using your phone, you can scan it, like scan the QR code, and then that will get you to the course, and you can just sign up for free. And the syllabus is actually right here, and it's pretty straightforward, and then it really helpful for you to get started with TARS. And our tutorial videos are also available on our YouTube channels. And if you just search TARS microservices, you can find us. And that's pretty much it. Oh, and our GitHub. Oh, actually, I couldn't get on GitHub for the moment because my network is kind of not stable.
Yeah.
And then for
sorry.
yeah, and then if you're interested in joining the TARS Foundation, you can read more information on the Join Now page. And I kind of like mentioned about how you can become a premier member or general member or associate member, and you can look at their requirements. And then for end user community, it's pretty we welcome all the companies who are interested in joining the TARS Foundation and getting to know other end user in the community. And it's if you just submit an application form, it's just as simple as that. Yeah, that's pretty much it. And you can absolutely check out our different channels. And if you have any question, definitely email me about the TARS Foundation. Yep. And
Thank you.
And again, remember to fill out the survey. It's a pretty short survey, and then we really value your feedback, and we want to know how to make our next meetup better. So please fill out the survey for us. Okay, I'll get the floor back to you, Isabella. Thank you.
Paige. Yeah, so stay tuned in our channels, and we create content not only for microservices, but also about open source development, open source communities, about developer experience in open source and different kind of things. So stay tuned. And does anyone have any other question, comments? Would like to point out something? Okay, so I think we can wrap it up. Thank you for attending the event. Thank you for the TARS Foundation for giving us this opportunity to learn more about microservices. And thank you to our speakers for sharing a little bit of their experience with us today. As Paige just mentioned, please just try to answer our survey so that we can improve next time. And that's it. Thank you guys, and have a great day or a great night in China.
Yeah, thank you all.
Thank you all.
Thank you all for the invitation.
Bye-bye.
Bye-bye.
Bye.